statistics generally, like whatever the data as it is, it could be presented in a what you call, whatever we are having together, and we are keeping it as it is. Okay, so that's it. So whenever we have this kind of data, like whenever we are trying to get the descriptive, like we generally get the what it is there, just like we are representing the data. So in the descriptive statistics, what are the main measures of central tendency and measures of variability? Central tendency, the word I think you people understood, right? Where is the actual meat, or what is the gravity, or where is the, it is more of the things are lying, right? So generally the central tendency is measured by the mean, median, mode that we discussed yesterday. So there is another measure, like that is a variability. So in the variability, generally this range, variance and standard deviation are discussed. Okay, so range is like whatever we discuss, like min and max, like generally that is one kind of range we can tell, like how many marks in a class we are getting. Again, we'll go back to the class example. In the class example, somebody might have get lowest of lower 30 or 35 is the lowest, like general pass marks 35 40 is the lowest. Even though there is a possibility of 0 mark or 1 mark also somebody may get, but in average case, if you consider min max is the like 30 35 and then maximum 100, but 100 everybody won't get, like on all subjects. Sometimes it is possible, but most of the cases 100 out of 100, like 600 out of 600, 1000 out of 1000, it is a very rarest of rare case. But then we'll come to know what is the, this is the range. In that range, generally we define the this variance and standard deviation. We'll go to the little bit in the variance and standard deviation in one of the slide. Okay, so whenever you are trying to keep whatever the values, right, like if you are getting the marks, like 30 students or 60 students are there in a class, in that class, how many got 100 marks, like take this, and this side is 100, like 90 to 100, you can make it a division, like, and 80 to 90, like frequency, generally in that range, what is the frequency, like 80 to 90 or 90 to 100, few people will get. Yesterday I discussed 60 to 70 or something, they will get the more, 60 to 70 or 50 to 80, thus that range will be more. And the rest will, again, some failed students, or maybe they got less marks and all, they will be somewhere here. So when you try to plot a distribution of that graph or something, you will get more or less like this. Sometimes this will be like right skewed negatively, like it will come like that, this side, if you frequency of all the people, right, how many marks they got and all. And this is this is called normal distribution, right? In the normal distribution, you do any natural instinct, this marks, salaries, whatever the numbers were, like even when you are some people are visiting the some shops, like generally people do shopping in the morning hour to evening hour. In the evening hours they will do most of the shopping, right? In the morning, compared to the morning and very late night, that evening hours are the most. So you can plot like this, like whenever any of the data is taken, and you take the frequency of that occurrences, and then you try to plot a graph, so it will come like this. Okay, so sometimes it is a like mean will be somewhere, like mean will be somewhere here, sometimes is a median will be here, sometimes. So sometimes like this is completely, whenever there is no skew, absolute normal distribution, that is called a mean, median, mode, then all are falling under this one. So but this is the rarest of rare case we get this kind of distribution. Sometimes we come to very close to it, but most of the naturally whatever the data, either right skewed or left skewed or something. So this is how it happens. Okay, when it comes to the range, variance and standard deviation, whatever the data you are taking, right, whatever the data you are considering, that data generally from mean, I'm telling the literal meaning now, from the mean, how far you are going, okay, that defines the variance. Okay, so here the whatever the mu is the mean, okay, and from there how far it is going generally comes. But standard deviation is also similar term when it is actually when you take it a formula, it is square root of the variance, actually square root of the variance. Why? Because this is a mu. From the mu means mean, right? Whatever we are considering, from there to some plus sigma and minus sigma, like it is called one sigma. So you people anytime heard about six sigma rule, some sigma rule? I think in nowadays in most of the
Yeah.
reels also people are hearing that sigma rule something. What is that sigma rule? From mean how far we are. If you are considering the six, if you are calling it six sigma, this side 3 and that side 3, 3 plus 3 6, that six sigma means you are covering the 100% of all kind of variations in the data. Okay, that is called six sigma rule. Even some companies, right, cmm level 5 or some above some is 9001, they follow six sigma rule, that 99.9999 is the 99 after point some completely six nines will come. So even if you are considering all this distribution of the data, whatever the data we have, so it may not become 100% again, there will be some slight error will be there. So that's why, see, that's why this guy put it 99.7%. Actually 99.9% is generally people take it as even in 99 point, but some error they will keep it. So whenever it is at plus 2 minus 2 sigma, that is called 95.4. So what you should take from this diagram is that generally standard deviation is the one, it is actually from which side, like it's a negative side or positive side, that sigma is called standard. Sigma is actually the square root of the variance. The variance is how far you are going from the mean. See, this is expected mean. Okay, this is the central tendency where your whole representation of the data will come. From there, how far we are going is the variance. Then that is the square root of the, again, standard deviation variance are same, but in order to count it as a some positive value, they first square it and then they make the square root of it. Okay. So this is what is this? What we are talking about is a measures of the variability. Okay. So we will then again, based on the conditions and all, right? Sometimes the frequency here, standard deviation is 5 here. Again, whatever the sigma rule from the mean, mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, that defines the thing. But here, whenever the mean is 100, whatever this part, right, here also mean is 100 only, both cases, but standard deviation is varying. When very few people are there, 75 125, some few people are there, sometimes this range also will be more number of people, more entries are coming here, or like more divisions are possible. So that time this will, this what you call this width of the this bell curve will increase. Okay, it is not always like, okay, we'll always stick to this is the height and all. No, it is not that one. It is the actually the density means how much, how many number of people are there, how much that thing is there, right? How many entries are there, that depends upon that standard deviation. So just to understand that literal meaning of how actually what is the standard deviation, actually why we are coming here. So whatever the data we are trying, we are just entering the frequency of the data. So that's why we are describing that in the form of the variability. Variability means how far it is moving from the range, like moving from the mean. What is the mean? The mean is the central tendency. Okay. Any doubts in this? This is actually, this is the core of the statistics. All things can be defined, or we can understand where we are going, how we are going, like how our general day-to-day life also we can utilize this formula, whether we are falling under the 6 sigma, 3 sigma to 1 sigma, like that. Okay. Okay. Next, I will touch upon the some of the things like distributions. See, whatever we talk spoken about the normal. This is a normal distribution. This generally it is also called natural distribution. Natural means you can take to any of the thing, any of the instance in your day-to-day life. Like if the rain is falling, like rain is like whenever it is there, what happens, it will start slowly, and then it in the middle of the that when it takes the pitch like high rainfall, right, that will go to the heavy rainfall, and then again it will come down, right? So the frequency of the falling drops, the rain droplets or something, right, that also you can measure like that. I'm just remembering some of the example, like you could be your marks, could be anything, right? It will all follow this normal distribution. But there are other distributions also, like that uniform distribution. These are also form of the natural distribution, but most of the fall under the normal distribution. So our most of the what we call formulas and everything, actually most of the form, not all the formulas, again fall under this normal distribution. Once whatever the data we have, that one we need to bring into the normal distribution and then apply the various formulas. Sometimes it could be uniform distribution, like if you are taking male and female, or generally we expect it to be equal ratio, right? Male female, or certain like if you are selling in a what you call some products in the market, like you are selling fruits, apple, oranges, or some bananas and all. So generally they want to maintain the uniformity in that whatever their sale points, right? Sometimes, like again, it varies. Like there are various kind of distribution, but mostly discussed, most of the formulas applied on the normal distribution. Okay, that is a Gauss. A Gaussian scientist is the scientist name, and he decided this part. Okay, and based on this, whether right skewed, left skewed, or other algorithms and all of the things are applied here. So it just in this slide, you just understand that okay, there exist various kind of distribution. In this normal distribution is having the more significant. So distribution, again, did you people, I hope you understood what it is, right? So you take all the data, whatever the data you received, you just plot it to the number of occurrences or frequency or whatever, right? So that either the data will fall any of these distribution. Okay, like if I think in the whatever the book I shared, right, in that book also, the how many times you are tossing a like coin, or like a dice or something. So they're recording the events, and they're making from distribution. So the frequency, generally how many times that is occurring, or like whatever the data you are trying to put, right, that one you will make into a things. Okay, so sometimes it will start heavily and it will go down. Sometimes generally our interest or some of the things, right? Sometimes our earnings also, our health also, like sometimes it will go up or down, or some like various kind of things we can follow. Whatever the data you are considering, that corresponding distributions will be available, and the corresponding formulas also available. And why we are doing this distribution, so that one should understand. So whenever we have certain distribution in our kitty, so from there we can take it to the next level to derive what is the estimates, like what is the next level things, like from the sample we are taking. Generally whenever health side, we are taking blood sample, and we are measuring the what are the number of what you call the bacteria or whatever, right? How the things are moving with that, what is the virus are infected and all. And we are estimating, okay, this is good, the severity of that infection or anything, right? We are getting through this by taking a sample, and we are measuring in the whole blood, right? So like that, in general also, if some people are having some issue, how to address that, or how to estimate. Like today, if you are conducting some cricket match in a small ground, how many people are appearing to that ground, like attending that ground. So based on that, if your same match is happening in the bigger ground, how much crowd will come, so that the crowd management people can take action how to do that part. So this is generally based on some sample data, we have to estimate the next level things. That's why we are taking the data and making the various distributions here and there, and then further, like we whatever we discussed earlier, right? So this mean, median, mode, variance, standard deviation. So everything is again goes back to the data, how to interpret the data and how to make the estimates at the next level. Okay. Okay, so as part of this distribution, data distributions and all, we'll have something like we discussed this normal, skewed, uniform. In that again, various things and all, and each one will have its own advantage, disadvantage, and each one will have its own formula and how to do with this data, how to go with the next level. Okay, uh, and we'll go to the central limit theorem. Central limit theorem actually. Uh, we discussed about the mean, right? And we discussed about standard deviation, right? So it could be any of the distribution, not only this normal. It could be anything. You figured out, you got some data. That one you took some samples. Okay, if a sample n30 is taken from a population with any type distribution, this is very important. Any type distribution. Any type means it could be any of uniform, Bernoulli, binomial, geometric, anything. So that has mean mu, something like mu, and standard deviation is sigma. And your sample distribution, and we took what is the sample. We should go to the back to the here. Again, these samples also various kind of sampling methods are there. Okay, so from here, that that sample will have a normal distribution and standard. Normal distribution is nothing but this bell curve, and then the standard deviation is this part. Okay, why they want to do like this? Because they want to apply the certain kind of theories or problems or whatever the formulas already existing, that one they will apply so that they can estimate it to the right way. Okay, that's why I was telling that this, whenever we have normal distribution, we have more edge in estimating certain things. Okay, that much, nothing much. Even central limit, we are trying to limit the central tendency, whichever the mean, median we are discussing. This one we want to bring it to the any of the data. If again it is not mandatory that always we should follow central limit theorem, but if we use, we can apply more, we can do data analysis more and more better way. Okay, uh, okay. Then coming back to the inferential statistics. So far we discussed about the descriptive statistics in earlier case. Now we will go with the inference. What is inference? Inference is generally whatever we have something, we need to bring some insights. Okay, how will you bring insights? Like whatever we discussed earlier, right? Okay, this is the data, and this data says so and so, right? Okay, this is a height, this many people are there, this many. So generally, so whenever, if we have some data, like what happens yesterday, we discussed some typical body temperature or room temperature, or based on that, like today in Hyderabad, 37 degree or 40 degrees around it is the daytime temperature. So what you will understand, okay, it is too hot, we should not go out in like in sun, or if we even if we are going, we should take care of some other. These are general, we are not deriving those things through formula, but we are getting that information, okay, based on the heavy temperature and all, you are inferring something, right? You are taking some understanding, that like we are taking some conclusions of that data. But if you are some robo is working on something, what it in which conditions it should work, right? Generally, even our temperature, like electricity supply also, if a higher voltage comes, what happens, the automatically the trip out, the whatever the fuse system or some of the things, whatever the mechanism we applied or in our panel board or somewhere, right? So based on that, it will trip out from there and it will not function, and it will hold on. And next, whatever, if the when the electricity becomes normal again, it will come back to the normal state. So like this, what based on some data, some sensor data, it understood that okay, the voltage is going up, so that's why it got cut from the service. So like this, whenever we have some data, from there we need to take the what we can do with that data. So that is the inferential statistics. So for every data, can we do directly? No, we cannot do directly. We need to use certain tools, certain methods, certain things. Those are all discussed under the inferential statistics. So whenever you are making any of the what you call data insights, right? You need to plot it first and understand what does it mean. Okay, plot means you should go into some graph methods, or the graph, putting under the graph is one of the common method. Even in the Power BI course also, you'll understand a lot of visualizations to apply, and from there you will understand how to keep this, as a what you call in a better way of what you call telling a story. Okay, how to tell a story. Okay, this is the data in the descriptive studies already, but from there we need to further bring out some insights. Okay. So in this, again, one important thing is this hypothesis testing will go. Hypothesis testing. Okay. At first level, very first level, even whatever the statement you are saying, generally the true we are okay. Before going hypothesis testing, I will tell one thing. Whatever the decisions, whatever the insights, or whatever the things you are taking based on the data only. Okay, nothing comes data driven decisions. Okay, so data, whatever the data you have, from there only you have to do some decisions. You should not use your own yeah, what you call, whatever the assumptions or anything. Okay, but how is it possible to do? When it comes, you can do this hypothesis testing. Okay, somebody said that a data analyst or data scientist salary is 50 lakh per INR per annum. Just is one statement. So without any of that one, first statement is taken as a data scientist salary is 50 lakh. Okay, per annum. So that one will take as a null hypothesis, that called H0. Generally, you can write this. You can take any of the statement, this one, and you can apply these methods in general, our general day-to-day life also. When I hypothesis, what is a null hypothesis? Just it's a statement, and what we are calling it is mu equal to, mu means mean, right? Mu is a generally we and we took how we took some data from where we took some naukri.com or somewhere we have some data, and we took some hundreds or 50 sample, 20 sample, or whichever the data you just pick it. Again, you can again to go to very depth and very perfect calculation, you go to the proper website or proper, you can ask the people and get the do. See, some people do surveys of also to do these things, even election surveys and all the, even some surveys are public opinions, even our whatever the negative reviews and all those things can be applied here. This, okay, you took some survey and salary of those people, some data scientists who were there, and we took it them, and then we calculate, I put all of them in one place, I calculated the mean. Okay, if that is, if I'm trying to prove this, I need to calculate all the data, mean of that one, and if it is close, it cannot be exact match. Okay, in some what you call, in some TV ads and all, they will give some gift if you find out some sari cost how much it was, but it is not that close. Okay, it is it could be anything like it, if it's close to the mean. So what mean means, again, the whatever the central tendency we discussed in the beginning yesterday class, right? So if it is close to that, your null hypothesis is correct. Accept if close to mu, reject if it's too far. Even nearby also you can take. What is the alternative hypothesis? That is called the data scientist salary not equal to mu, not equal to, we are saying this, right? Not equal to. So whatever the statement you are doing, or whatever the understanding you have, you can divide into the two things. One is the null hypothesis. When is null hypothesis correct? When the particular statement is close to that mu. Like we can make that statement. Okay, we can directly take the data scientist salary is 50 lakh, but how? Based on that, some by measuring some central tendency, what is the mu and all from there. So like that. Okay, like you are assuming something like, what is the cost of land in some place, or what is the cost of stock price. So like this, you can do your own testing. Actually, you can get the proof of your own statement. You can take any statement, and based on that you need to work. Sometimes it is not mu, something else also we may take. What is the range of the, see, today some cricket match is happening, so how much the score will be for team A? So it could be more than 200 to some 250, that range. That also you can make some, if it is near close, it may not be exactly, but it is close to that one, your hypothesis, whatever hypothetically, your null hypothesis is correct. If not, alternative hypothesis is correct. So finally, what we have to prove here, why we are doing very low level thing here, that one shouldn't thought why? Because this is the stepping stone, or first step to take the decision based on the data you have. Okay, and this, whatever the null hypothesis and alternative hypothesis you are calling, right, it generally comes from the whatever the data you have with you. And you cannot take worldwide data and do say something and all. Again, okay, that also agreed, we can take. But if you have the data, whatever the data limitation, how much data you took, and from where you took, which domain you took, so those are all again comes the limitations of the any hypothesis testing we are doing. Okay, so what is what we achieved from doing this? What we achieved? Anybody? By
We
doing
got some,
hypothesis?
we got inference.
Exactly. So that is one kind of inference. You are telling it is a true or false. Either you are accepting the null hypothesis or going with the alternate hypothesis. Okay. Again, when you go to the alternative, if this is leading to this one, some other conclusion you can make, some more statement further you can divide that problem, or you can further like you can make as many as problems, and that one you can do hypothetically you can test it and then say it is true or false. Okay, like that you can do many number of things, and based on this many tools, actually many company policies, many companies like even governments and everything, right? So they go with this kind of testing in order to take some decision. Okay, so that is a rule, very basic step of the this inferential statistics. Okay, and then this uh, inferential statistics other use case is that confidence intervals. Confidence intervals is like whatever we discussed this, no? Generally, see this also called, what is this? Okay, mu plus sigma, mu minus sigma. The sigma, what is the uh, from where to where? Generally, range we are trying to tell. Okay, so that confidence interval says the how, what is the range if you want to define that, right? That will comes the this part. So what is the role in estimating population parameter? So whenever we are doing all this, basically when it started, this subject started, they take the sample, from there they try to find out the whole picture of the whole population. Okay, so that is what they were doing. Like generally they take some normal distribution, or using central limit theorem or something, and then they will figure out, okay, this is the data, this is this many people pass. Like here in the out of 1,000 population is 100 sample you took, and in that 10% people failed. So 10% in the 100 people, 10% people means in 1,000 people, 100 people may fail, right, or may pass. So that is how they project the big picture. That is the original idea of the, like, by using the sample we are estimating the population parameters. Okay, so there again, like how far you do, again whatever the how sample you are taking, again you'll go back to the what is the data type, to what kind of data, how you put, whether central tendency again. So here one of the thing is that what is the like range of the data you are taking, which range and all. So confidence interval gives the generally which sigma, like which took the plus sigma, plus 1 sigma, plus 2 sigma, plus 3 sigma, right? That is the role of it. Okay, the certain population, certain confidence interval give the more information, certain confidence interval like it doesn't give any information. Okay, then this a point estimate versus confidence interval. Again, point estimate is always says the single point. Generally if you are trying to say a mean, okay, again we go back to this rule. So mean is the point estimate. You can say that, okay, this is the mean and this is the fixed one number you are telling. But if you want to say the same thing in other using the variance or range or standard deviation, right? You use the other parameters, right? So okay, the value you may not tell all the time point, like what is the price of this thing, or what is the price of so and so stock value, or what is the price of the land value, or so you will try to tell some range. You may not but certain times it is always possible to keep the point. So that is called point estimate. So we are again, the inferential statistics actually depend, we are estimating something based on the available data, and that available data also we are sampled out, and from there we are trying to estimate. Okay, so that is the inferential statistics. So all the people may get one doubt or should get one doubt. What is that? Is it really possible to get the, if you have some sample, is it really possible to estimate the bigger picture? Are you getting, any of you got this doubt?
Yeah, actually, if we can see one small example of this hypothesis that you explained, how do we decide what is the hypothesis and how do we prove
Yeah,
about
yeah.
it.
That's what I gave the example here related to the data scientist salary. You take that something like that. We are taking something like that. Wait. Okay. You tell. Okay. Some of you like here who are there. Madhu is there. Just we are telling the names. Salis. Two things. Okay. Names. All are data scientists. Okay. Madhu. Pavan. Venki. What happened? Mamsi, Vaishnavi, something. Who else there? Somebody in this team. Who else? Madhavi. So somebody. We took something. Okay. Here we took some like some 20 lakh. 10, 20 lakh. I think I put 2 lakh. Okay. One minute. Sorry guys, there was some important call. Okay, so you are able to see my screen, right? Okay. So yeah. So something like this, and okay. So Sam, these are the generally salaries you surveyed, or you got it from Naukari, or you asked some people. This data should be collected. Okay. Somehow, from where you will collect? You will collect from various things. Sometimes survey, sometimes this, sometimes what you call by asking, sometimes. But this data generally, can we call it whole data only? This much only actually we have. But assume a case, we have some 5,000 people data or some 100 people data. 100 people data we have actually. Okay. But here what happens? We took some sample of how many people we took? 6 people, right? 6 people only sample. Could be sometimes 20%, 30%. One more thing is, one practical thing is that any data, 30% of the data should be sampled out. That is a very good thing to do generally. But it is not always possible to do. Okay, if you are really sampling out certain data, that makes more meaningful. 30%, like 1/3 of the data. Okay, that is practical scenario. Sometimes we end up doing various kind of data. How much you require to create a model or something like that kind of thing. So this sample data, when we figured it out, generally what is this sum, right? What is the when you try to what to call view? What is coming? Formulas are there in this. So average you are trying to. What is the average you are getting? What you are getting this much. So before going there, when you take the sample, right, you need to define the H0. What is H0? So we took the salary of the data analyst people. The salary of the data analyst is something, right? Is a 50 lakhs something. So now what happened to it? This is a statement. This statement you should take as it is, as a null hypothesis. Like you're starting with that. Okay. So this should give some idea like how to play with your statements, whether it is supported by the data or not. Till that point you take understand. Okay. So how it supports by data, like you are taking anything, like you are taking, okay, our city population is this much, and what you call, they need this much water every day or something. That is a statement. Generally you take any statement into the null hypothesis. So that is support, that should be supported by your data. So if I'm trying, then what happens, I will go back and get the data wherever that data is available, and I'll try to apply this kind of method. Where it went? Okay. So I will try to apply that method. What is this? Okay, is it true now? What is the, when you calculated that mu? Why we are calculating with the mu here? So general tendency, right? We are estimating the whole population actually. Salary of the data from 100 people data is there, but 100 people we are assuming, but we have sampled this much data only. Or reverse, we picked few data, like already 100 people data is there. In that some 6 people data we took as a sample. In that sample, we try to figure out what is the average. What is this average? Is a mean, right? Average is this much. Whether if it is, why again this average is, again we discussed about central tendency. Generally it represents that whole set of data. If this is, it may not be exactly 50 lakh, but at least close to. If assume a case somebody is having some other itself is having something like 50 alone. So what is the average becomes here 30. Somebody else is having who else is having, okay, Pavanana is having some, okay, 70. So 70 lakhs is their salary. So still what is the average? It became 38. It is close? No. Again, if it is coming something like, okay, somebody else is also having 50, maybe it may come to close, right? But I'm just manipulating the data here. But general data we should take the what is available from the sample collector. You should not change the sample data. Okay, should not fudge it generally. What I put here actually 50, right? So what? Okay. Now this average also, whatever we expected line, it came. That time the null hypothesis is a general fair statement you are trying to give. Okay. So that one it gets validated. So whatever this statement is supported by your data, you can say anything, any statement. Like, okay, somebody achieved so and so, somebody did this, somebody did that, like anything, right? That one. Okay, today's salary. Okay, now if you take stock market, what is the null hypothesis of certain values or certain stock value or something? What could that could be, and that should be, this should give the way to how to approach the data based decision or data based agreement to the statement. Okay, this should be supported, whether it is not, you are not testing this, actually you are testing this data, whether the statement is supported by this data or not. Okay, generally when we are doing hypothesis testing, you will think that okay, you are testing that state, but actually with the data you are testing the data, this data is really in alliance or in compliance with this statement. So that is how the null hypothesis. Okay, if this is not working or this is not at all coming close or something, we change it to some what you call this this information, we change it to the 1c. That list is a 1 crore. Okay, so when it is 1 crore, what happen, whether it is too far from the mean, right? 1 crore, the mean it should be having, then what you should do, then we should say that this alternative. See, this notation is a little different from book to book and all, but yeah, You can take anything. Okay, the average is not equal to actually. So not equal to. So we say this way, and salary of the somebody is not that one. So if not, again, what we can take some more conclusion, that one either you need to divide this problem either lower side or higher side. One more statement like that. But everything should be supported by data. Without data support, you should not take any of the thing. Either you are concluding, okay, here I'm accepting the null hypothesis or rejecting the null hypothesis, or if I'm accepting the alternate hypothesis, or so step by step you need to take the data agreement with the data, whatever you are agreeing to the data on the your statement. Okay, so whenever you are analyzing the data, like we are learning a course for the data analysis, right? So it should be supported by some see, if I'm getting some dream, I will go with that. This is when it comes to the data, right? It is not that case. Okay, it should agreed by that data, whatever it is saying. Even simple like mean, median, mode, and all these tools, like there are 100 different tools, methods, or many things are there, that all these things can be used to come out with some acceptance with the data, whatever the statement you are making. Is that clear, Dhaval?
Yeah, yeah.
Hmm. Okay. Okay. Hmm. So, yeah, this one I will come back. Okay, so there are some tests actually. We are not going this much levels actually. This T test, the Sky Square, and ANOVA, like whatever some the test, right? These are more ANOVA is analysis of variance. T test is that generally you are taking the samples, right? Whether whatever the sample you took correct or not. How do you know? Like you are, we discussed about some of the samples you took right here. You took random sample. How many you took? Some 1, 2, 3, 4. This circles one you took. Whether how do you believe that your sample is you are taking correct sample or not? Even whichever the sample you take, stratified sample, cluster sample, systemic sample, systematic sample, anything, right? So if I'm picking two or three or more and comparing them, their means and all, okay, my sample is okay. That way we can conclude, right? Like today, whatever you want to eat something today, one samosa you ate one thing, and second samosa, third samosa also looks similar. Then you can certify, okay, it is made from the same shop, something, right? The sample is very much okay. So like that, this whatever we spoke about the t test is a twisted actually pairing. It's a pairing test, and this chi-square is generally whenever we have the two categorical variables, right? That time we use, and this ANOVA is when two continuous variables are there. So again, whatever sample we are taking, whatever we are doing, that one. So mostly for the data analyst course, we are trying to map the data and all this test and all, who are really working as a statistician or some level of estimations and all we are doing, they will do all these things. But um, they may not, as a data analyst and people may not use extensively. Yeah, if required, you can go through these things, what test need to be used and all. I'm just giving the hints that what we can go from here, where we can go and all. It is not like too much required now, because we are learning actually Power BI and data analyst and all, right? But I'm just giving the glance, like, okay, where we can do and what we can do with these things. Okay, so yeah. uh, One more thing, this is actually will come to the whoever starting with the machine learning, data scientist and other all people. They need how to represent the data from one to, like, when we are taking the two variables, right? Two variables means um, xy, generally you try to map between the relationship, right? If x is growing, y also grows. That, like, generally correlation, when we call it a relationship between the one variable to other variable. So like If in a classroom, when two people are there, one person is studying means other person also will study. Generally, if they are friends means okay, this guy gets pass, other guy also will get pass. If this guy is also feeling that, so some try to make some relation. Like generally, if you are taking the relationship between months and the sales, right? See, certainly this festival season will have some more sales than the normal season, and movies will run well when there are holidays to the students. So the relationship between this thing and that. So when the petrol price is hike, there will be less purchase of the vehicles or less more usage of the public transport. So some relationship we can make. That is generally uh, particularly say this all data, right? They try to find some relationship between the one variable to the other variable. So uh, when yeah, I will come again. This I will finish this and we'll go there. Okay. So sometimes positive relation, sometimes negative relation. Okay. And there is other word is a regression. We try to like do the if you are trying to like I want to predict or estimate the what is the price of the particular product, like cameras or TV in future or mobile. Today it is some 20,000 rupees. I purchased a mobile. So same thing would be next year. What it would be? So mostly people think that okay, the electronic goods it will be less, but in the same 20,000 rupees, you may get the better featured mobile in the next year, right? So like this, so there will be this regression technique is mostly used in the estimating the price estimates and price elasticity, where it is standing, where it is going. But this regression will come based on the relatable variables and all, if you are taking into the consideration, and then do the prediction on the part. Again, this prediction, when regression will come, what is the one value, by summing up, by doing some math, this, that, and all, putting all of them in the mixture and all. So then you will try to figure out a value. Okay, yeah, given based on these given conditions, you will get the next. So next, this is going to be value. So uh, this how to make the correlation and regression is mostly you may not do as a data analyst and all, but sometimes you may need to do very rarest of rares. But correlation is always you people need to do when you have two variables, how to relate them. So very beginning we discussed about certain what to call one thing I kept, right? So generally, what is this relationship between this variable and this a b c, three in the three time zones, they're using the different things, right? See, this is a correlation. Generally, you are trying to, when particular variable is going ups and down, other variable also similarly it is showing some relationship. So this, see, this blue color hikes and dips, right? Um, Again, then the orange and yellow color. So this is generally you are trying to bring out some relationship between the variables. Okay, so that relationship, how it would be, it should be positive, negative, or different direction, and so that time you understand how you keep that relationship between them. Okay, and uh, I'm not going too details in it, because it's again big subject. In the regression also some thousand different methods are there, which regression to be followed, which correlations we need to take, and what will happen if in particular correlation, how to estimate and all. So this when you study more and more in this zone, it becomes a what you call you're stepping towards the data science, machine learning, and other algorithm. Actually, statistics, the subject actually paved the way for current day machine learning, deep learning, NLP, or whatever, even artificial intelligence, this robots and everything, right? Robo also, if you take any robo movie or anything, right, it takes some decision. Why, how it takes? It definitely takes like data driven decision. Whatever the data it has, right? Based on that only, even whatever the currently some commercial or scientific robots which are being created, right, it will take all the based on the data driven decision only. That is what that artificial intelligence, like our general human intelligence develops this by naturally uh, all these things you are whatever the statistics concept, right, you are doing naturally in your mind, like how much you're gonna spend when you go out, how much fuel you need to fill, or how much cost you are going to bear for how much land, like if you're buying some land or product, how much you can expend for that. So all these things you are doing internal, some calculation, some method you are picking up, some method it may be correct or not, that is a different case, but you are picking that calculation, right? So that is you are applying the statistics. But when you are giving it to the robo or some other device, right, it has to take some decision. How it will take, it cannot that is called artificial. Artificial is again from the data it will calculate and bring out some information and put it there. Okay, so we are in the like very drop in the ocean, like, so we are learning these techniques and maybe applying some project or something. But yeah, big pictures are still there. So some all whole humanity is working towards bringing this artificial intelligence and other things, right? So we are also learning in the part of it. Okay. Mm. Okay, then I will conclude a little bit with I think people always when it comes to the statistics, like mean or median mode, before that central tendencies and some measures of central tendency, measures of variability, and then the testing methods and distributions. These 5 points whatever I told, no, these are very much important. You will come across now and then, so you pick them even when you are practicing with other data sets and all. Okay, so with this we can take any decision like with confidently, like we will have some information, right? Particular decision you are taking means with the data support you are taking. Okay, and you explore more and more statistics. You will really enjoy the fun with this, because this is actually, it is very old science, but you can predict so many things for the future stuff, like you can estimate the things and all. You can do lot of even if you are if you are alone or something is not what you call, you are not, you do not have friends, you like your friends are not reachable, your whatever mates are not reachable also, you can take some strong decision, like confident decisions with the data support. Okay, the data you can think of, okay, how can I apply your data, whatever the data points you have, you can formulate, you can keep it in Excel sheet or and all those things, and you can do a lot of things with that. Okay, so start applying this whatever the learned things so far in your daily life also, you will enjoy the fun. Okay, so I'm concluding the statistics because I'm not going too depth into the study, because that much is enough for the our stuff. So we have some 5 more minutes. I will just give the some more information on the see, these Excel sheets are very much useful. Okay, start playing with the Excel sheets left and right. Even if you learn anything or not, learning Excel sheet is very productive thing. Okay, this Excel sheets actually in one of the interview, Bill Gates, Microsoft founder and chairman, right? That guy was telling what is the most like what is the which product he will be proud of. So he'll say that Excel sheet, like whatever the Microsoft Excel. Of course, Microsoft Excel, like Google spreadsheet or anything, right? They all follow same formula, same thing and all. So it can do any of the things whatever currently we are discussed today, statistics or other things and everything, right? It is possible very much, like whatever the data you are trying to draw and all those things. Okay, as part of this discussion, maybe in the Power BI also extension of the Excel sheet only, but it will do more data cleaning, more stuff and all, some more articles, some more dashboards and all, right? Here also we can create some kind of dashboard, but more looks like static, but there we can create dynamic dynamic dashboards and some buttons and all. This is like little previous version. Okay, so when it comes to the what to call, something like that, right? If you take some picked some data like this, and you can